This is lesson 12.2, experimental probability. So in lesson 12.1, we talked about the chance of things happening, and we could just think about a coin. Hey, what's the chance of it landing on tails? Well, that was one half. And we could just kind of know that. Same thing if I was to roll a dice, the chance of it landing on a four, well, there's one four, and there's six sides, so that's a one out of six. But you can't just know everything like that. And this first example is a great example. Dorothy is in a soccer match. The very first day that Dorothy plays soccer, I don't know how good of a player she is. Like, I know nothing about her. I can't just look at her and make a judgment. I need to actually like watch her play and see if she's good at it or if maybe she's not so good at it. So, um, experimental probability is found through repeated trials of me like watching someone play or doing an experiment to figure out the likelihood of events. So Dorothy is playing in this soccer match, and at this point in the game, she's taken 11 shots and scored 3 times. What's the experimental probability of scoring a goal on her next attempt? So we've got right here the probability of scoring a goal with our math notation, and she scored 3 times out of her 11 shots. So the chance of her scoring a goal on the next attempt would be 3 out of 11. In our next example, Sarah's Yummy Foods store sold 10 biscuits and 9 of them were plain biscuits. What's the experimental probability that the next biscuit sold will be a bagel? All right, so this is one of those get more math tricksters. They want us to be like, oh, 9 out of 10, la la la, done. No, you've got to watch out because the top of the problem talks about biscuits and the question is asking about bagels. So the chance of us getting a bagel ain't gonna happen. There's no bagels in this biscuit store. So the probability is 0. I can organize my experiment in a table, and that's what happened with this problem. A bag was filled with colored items. Cindy repeatedly drew one at random and then replaced it. She did this 15 times, and she recorded her results in the table. So um, they want us to know what's the experimental probability of drawing a black item. Right here, probability of drawing a black item. I look at my table, I find the color black, right there it is. There's 4 times in Cindy's experiment that she got a black item, and I know that she did this 15 times because it says in the problem, but if I wasn't sure or if it didn't say, I could just add up all of these numbers, 4, 1, 4, 3, 3, and that's 15. That would give me the total time. So either option. So the chance of you drawing a black item is 4 out of 15. And our last example, Finn had 9 at bats. He got hit 1 time. We want to know the experimental probability of not getting a hit on his next attempt, and they want that as a fraction. So not getting a hit, well, he hit the ball 1 time. That means that he missed or didn't hit the ball 8 of those 9 times. So the chance of him not getting a hit on his next attempt is 8 out of 9.